Hello everyone, as fast as possible I'm going to try to show you how to use Oscillo program and configure it and get running with your system. As we said before, Labview is a system design, platform and development environment for a visual programming language from National Instruments. So first, go to oscilloapplication.vi and open the program. When the screens appear, you need to enter your user and password to get access to the main program and create your own session. But the access will be denied if the login or username is wrong. So let's try the whole thing again by entering the user and the passwords. After that, we can see here the whole development interface with its different tools and functions, which will be exposed one by one using an example. So here we have two tabs. One-dimensional signal contain 4 parts and two-dimensional signal contain only 2 parts. And we can scroll down to better visualize the developed interface. To understand the application that we create, we need to try an example. So first, let's choose a type of waveform like square and configure it by modifying or choosing frequency, increasing frequency multiplier and amplitude. And for the second signal, let's pick sine as a wave or as a type of a waveform and configure it with the same configuration of the first signal with frequency multiplier and also amplitude. We can modify scale of every signal with the two commands. msdiv modify the time axis and volts modify the amplitude axis. msdiv, yes, and volts, also like this. So what we need here is to increase the frequency of the second signal to better visualize the sine waveform. Okay. We can also export data to Excel to read the value of every point of the signal. The first time and amplitude is for the first signal, and the time plot 1 and amplitude plot 1 is for the second signal. The next tab is time and frequency analysis. Here we can produce signal spectrum for example, using FFT, which is fast Fourier transform. It converts a signal from its original domain to a representation in frequency domain. And we can also choose FFT shift command in order to better visualize the signal in the middle of the screen, like this. Then there is the oscilloscope tab. It has the same function of the typical oscilloscope instrument, which used in electronic laboratory or other places. By just clicking in the oscilloscope tab, another window appears to choose where do you want to save your work, like this. Okay. We will work with the same example of square, and what we will do here is we can add noise, Gaussian or uniform. We can also modify scale by msdiv for the time and volts for the amplitude. We can save file, and also we have a block indicator. So let's try it. Okay, modifying msdiv for the time axis and volts for the amplitude axis. We can also add noise, and we can hear the noise. We can change the Gaussian and the uniform noise. Gaussian, it's the Gaussian noise, and the uniform. And also here we can see the measurement, the amplitude, frequency, phase, mean, max, and mean volts, and peak to peak. And finally, we have the display signal sound, which allow us to visualize or exactly to hear the signal. This is usually used in many fields, for example, medical or specific frequency, sending specific frequency for specific work. So let's pick any type of signal by modifying the signal type, like this. By modifying frequency range, you will notice that the signal wave change and even the sound. So let's try it. Random signal. We can modify the frequency range, and also we can modify the block size. Also, you can create your own signal using the lowest frequency and the highest frequency. So let's try it. The lowest frequency and the highest frequency also, and modifying the block size like this. You see it? Okay, lowest. Same. So that's all for the first or the one-dimensional signal. For the two-dimensional signal, we have two parts: two-dimensional signal processing and two-dimensional image processing. For the two-dimensional signal processing, which allow us to produce the spectral of the two-dimensional signal that we choose. For example, we will pick pulse as a type of image, and then we'll apply the 2D FFT in order to obtain the signal spectrum. As we can see on the graph, there are two things: sync on the x-axis and sync on the y-axis. We can also modify the parameters using the amplitude, the asymmetry x for the triangle, and the asymmetry y for the triangle. We can also apply the 2D FFT shift like this. The next part is two-dimensional image processing. By just clicking on the tab of the two-dimensional image processing, another window appears to select the type of the image that you want to work with. For example, let's pick any type of image. The two-dimensional image processing is based on three colors: RGB, red, blue, and green. It has the same function of the two-dimensional signal processing, but now with image. Using the FFT or using the after inverse FFT for the blue channel and the after inverse FFT, and we can also modifying the parameter using the intensity. That's all for our developed interface. Hope you enjoyed.